All right, so this lesson is going to go the other direction. We've been working on finding factors and roots from polynomials, and now they're going to give us roots, and we're going to try to go back and find the polynomial problem that they would have had for us originally. So you all know from how roots and factors are related by now. So right, if you have a root of 0, that means on the outside we just have an x. One of the things I want to point out before we even begin, and I should have said this first, the first thing I think you always should do is state what the degree is. Remember, when you look at the degree, that tells you how many roots, so we're going to go backwards and say that just so we make sure we end in the right place. So this has a 0 multiplicity of 3. That means it's like 0, 0, 0. There's 3 of them. There's a 1/2 and a -5. So right now I know that this has a degree of 5 because that's 5 different roots. 1, 2, 3, 4, 5. So I know that my final polynomial should have a degree or a term x to the 5th at the beginning. All right, so let's go ahead and start writing our factors. So I know if I have a root of 0 that I have a factor of x, and that's a multiplicity of 3, so you can either write x out 3 times or we can just say x to the 3rd. I know if I have 1/2, that must have been 2x minus 1. And if it's hard for you to jump that far to begin with, you can write x minus 1/2, and then remember that just must mean the bottom comes up. And then a root of -5 means the factor must have been x plus 5. Now, in these questions, they're going to want us to simplify this polynomial, which means they actually want us to multiply that out to figure out what it would have been to begin with. So what I'm going to do, generally I'm going to hold on to the GCF until the very end. Remember, because I'm working backwards, so what normally is the first step is now going to become the last step. And I'm going to multiply these other parts first. So this is going to give me 2x squared plus 10x minus 5. And now I need to multiply the GCF by all of that because it would have come out of all of those things. So when I do that, I'm going to get 2x to the 5th plus 10x to the 4th minus x to the 4th minus 5x cubed. And then the last thing, I kind of hesitated there because I was confused about why this x to the 4th was happening twice. It's fine. All we need to do is simplify in the end. So I need to simplify my final answer to be f of x equals 2x to the 5th plus 9x to the 4th minus 5x third. All right, and that is the simplest polynomial that we can write for that equation. Now, of course, you know this is Algebra 2, so it's not going to be quite that simple all the time. So there's these two theorems, and we've talked about this before in your notes, but we haven't spent a ton of time on it. So there's this statement up here at the top that says, remember when you do quadratic formula, you get this plus or minus. And what that does is it always creates what we call conjugate pairs. So there are two theorems here, and one of them is that if you have irrational, that means something that has a square root in it, you're always going to come up with conjugate pairs. Notice these pairs that they have listed for you here as examples. Positive square root of 5, negative square root of 5. 1 plus square root of 7, 1 minus square root of 7. All right, those are all examples of conjugate pairs for irrational roots. We also know that these same conjugate pairs happen for complex or imaginary roots. And they give us some examples there too. They give us positive I, negative I. 2 plus 14i, 2 minus 14i, right? Those are always going to come in those conjugate pairs, which, remember, conjugate just means they're exactly the same, except for that they've got an opposite sign in the middle. So let's look at how this changes that process of writing equations. All right, so this one says, remember, the first thing we want to do is list the degree. And really, I've kind of lied to you because the first thing you want to do is say, do we see all the zeros that there actually are? And I notice that I've got a 5, all right, that one's fine. And then I also have a root of 3 plus 2, 7. This is an example of that irrational, which means I also know there's another root, which is 3 minus 2 square root of 7. Okay, so now that I have all the roots listed, the degree I know here is 3. So I'm going to go ahead and set up my factors. So I'm going to have x minus 5. And this gets kind of weird, all right? I'm going to do x minus 3 plus 2 root 7, and then x minus 3 minus 2 square root 7. All right, notice that I'm putting those in parentheses because I'm trying to subtract the entire root there. All right, now we're going to just work on simplifying. And the first thing, to be honest, the first thing that I want to simplify is this. That looks gross, and I don't want to look at all those parentheses. So I'm going to distribute first. That's going to give me x minus 3 minus 2 square root 7, x minus 3 plus 2 square root 7. All right, and now this is where we're going to need to distribute. So you can do where you're distributing each of these three terms, an x, a negative 3, and a negative 2 square root 7 to the other set of terms. But to be honest with you, I think to keep this the most organized, I think our box method is actually going to help us the most. I know some of you are not the biggest fan of that, but I just think it's going to help you kind of keep track of all the pieces a little bit better. And there are going to be some nice things that happen with this once we multiply this out. So I'm going to go ahead and set that up. X negative 3 negative 2 square root 7, x negative 3 positive 2 square root 7. And I'm just going to go ahead and multiply all of those terms out. So this is going to give me x squared negative 3x x times 2 square root 7, or 2x square root 7 if we want to write it that way. It's probably the best way to write it, 2x square root 7. All right, negative 3x, positive 9, negative 6 square root 7, negative 2x square root 7, positive 6 square root 7, and then that's going to give me negative 4 times square root 7 times square root 7 is square root of 49, which is just 7. Or you can write negative 28 here in this last one. Now, like I said, there's some nice things that are going to go on here even though you don't realize it. Notice that you've got these things that cancel out. The gross ones, all those square root 7s are going to cancel. Right? You got opposite pairs there. So now we just need to write everything that we have left. And from this whole step, I now have x squared minus 6x plus 9 minus 28. Or we could even combine the 9 and the negative 28 to have negative 19. All right, so that's nice. That's a lot easier than what it looked like in the beginning. And now we still want to bring down this x minus 5 because we haven't used it yet. And we're just going to distribute one more time to try to get our polynomial. So I know these problems are long. You won't have a ton of them to do, but you just need to get the general concept of how to do some of these problems. So if we go ahead and distribute there then, I'm going to distribute the x first, x squared minus, or sorry, x to the third minus, what am I doing? To the third, minus 6x squared minus 19x, and now I'm going to distribute the negative 5. That's going to give me positive 5x squared plus 30x plus 95, and then just simplify. X to the third minus x squared plus 11x plus 95. And f of x, and we just want to check that we have the correct degree. And in the beginning we did say that we wanted a degree of x to the third, which is what we got in the end. All right, here's one more problem that we're going to try. I'm going to go much quicker on this one. I just want you to have another example to hopefully make the most sense that you can out of this concept. All right, so remember, we want to list any pairs that we don't see. So since I know that's imaginary, there's probably also a root that's 1. It's not probably, there is also a root that's 1 plus I. So this has a degree of 4 because there's 4 roots now. We'll go ahead and write our factors: x minus 2, x minus 3, x minus 1 minus I, and x minus 1 plus I. Again, I'm going to focus on this imaginary part first, simplifying it. So that's going to give me x minus 1 plus I, x minus 1 minus I. Okay, I'm going to set up the box again. Ooh. All right, x negative 1I, x negative 1 negative I. Then just multiply. It's going to be x squared minus x minus xi, negative x plus 1 plus I, xi, negative I, and this is negative I squared. Same like last time, the i's are going to cancel out, the ones that we don't want to deal with. Negative I squared, this is something you need to know. All right, this is negative. I is the square root of negative 1 squared. All right, so if we square the square root of negative 1, that's going to give me just negative 1. So that's negative negative 1, which is positive 1. I'm going to show you how to make your calculator give you that also in case you ever get super stuck there. So really, all of that was just to give us x squared minus 2x plus 2. All right, that's the plus 1, and then this positive 1 down here that we just got. And then we can pull down these other factors. All right, that's going to give me, I'm actually going to go ahead and multiply that out as well. If I distribute that, that's going to give me x squared minus 3x minus 2x plus 6, which when I simplify will give me x squared minus 5x plus 6. And just to keep yourself organized, you can do the box again, and that's what we're going to check probably as your warm-up tomorrow. So I want you to try one more time to multiply this out and just finish your notes for yourself. See what you're going to get as your f of x there.